everyone! My name is Julian Nunez and I am the tribe leader of Hytham Group. So before we proceed to our topic, did you know that math is an integral part of providing in practical solutions to many industrial problems? That is why at an early stage, math, students are taught to solve different problems so that they will be able to see that they can apply their mathematical abilities to find a solution to any problem. Unfortunately, some students hate math because there are difficulties in the subject. So, a man once said, "Do not worry too much about your difficulties in mathematics. I can assure you that mine are still greater." This man is Albert Einstein, the only proves that even the brightest minds encounter difficulties in math, but what more important is overcoming these difficulties.
Reasoning is the action we do whenever we want to think or say something in a logical, sensible way. This is like a go-to-defense mechanism when we want to justify our actions and statements. To other people, reasoning is often a highlighted topic in various fields like philosophy, science, language, mathematics, and art, and normally considered as one of our distinguishing abilities as a human. In logic, reasoning is the drawing of inferences, conclusion from known and assumed facts. The two major types are deductive and inductive. These refer to the process by which someone creates a conclusion as well as they believe their conclusion to be true. The first type of reasoning is deductive reasoning. It is the process of reaching a conclusion by applying general ideas called premises. This concept is often expressed usually using a funnel that narrows a general ideas into a specific conclusion. It also recognizes rules, laws, theories, and other widely accepted truths that are based to prove a conclusion is right. The most common form of deductive reasoning is the syllogism. Syllogism is a form of deductive reasoning where can arrive at a specific conclusion by examining to other premises or ideas, where two premises that share some ideas to support a conclusion. Example and simple. A implies B, and then B implies C, therefore A implies C, where A and B and C are proposition or the general ideas that we're referring to similar to transitive property of equality. If A is equal to B and B is equal to C, then A is equal to C. This R is also similar to transitive property of equality, where if we have A plus B or A equals B or premise and B is equal C is another premises, then A is equal C because both are equal to B, for example.
For example, men are cheaters. John is a man. Therefore, John is cheater. In symbol, let this A implies B and B implies C. So we can see there are B are same, so A implies C. For other examples, all even number are divisible by 2. 22 is an even number. Therefore, 22 is divisible by 2. Since we have the same ideas here, therefore 22 is divisible by 2.
Think of this example. All musical instruments, one makes sound. Tricycle makes sounds. Therefore, tricycle are musical instrument. The first premise, all musical instruments, one makes sound, is true premise. Also, tricycle makes sound is true premise. But tricycle are not musical instrument. So this is not a valid deductive reasoning. Always remember that we use premises to prove the conclusion is true and not to justify. Deductive reasoning is meant to be demonstrate that the good conclusion is absolutely true, based on the logic of the premises.
In other hand, inductive reasoning is the process of reaching a general conclusion by examining a specific observation. So, a few particular premises of create a pattern much give way to general conclusions that is like time. This is commonly shown using a triangle that starts at the narrow premises and expands into the broader conclusion, unlike, has no basic standard format when used it. So as long as we are finding in a conclusion that is mislikely to premises, we can make prediction, create generalization, and analyze cause and effect. Keep in mind that deductive reasoning premises are used to prove a conclusion, while inductive premises are used to predict a conclusion, meaning we don't create a definite answer, but we're trying to show that the conclusion is the most probable given the premises.
For example, yesterday morning, Jed went to jogging this morning. He jogged again, therefore, Jed will probably jog tomorrow morning. This conclusion is not definite, but basing in the morning routine of Jed, there is high chance that he will jog tomorrow morning, right? What if, like these examples, we are asked to find the next figure in this pattern? The first figure is a square. In the second figure, a second square was constructed inside of the first square, wherein the vertices of this new square are on the midpoints. If the sides of this square following the same pattern, and by using inductive reasoning, it's possible that the next pattern is this one.
Problem solving with pattern. Term of a sequence. An ordered list of numbers such as 5, 14, 27, 44, 65 is called a sequence. The number in sequence that are separated by commas are the term. Example number 1. Predict the next terms to sequence. Use different table to predict the next term in the sequence 2, 7, 24, 59, 118 to 207 blank or the missing term. So, how are we going to predict the next number in the sequence using the pattern? Solution. First, copy the given solution. Next, find the first differences. Then subtract second differences. If the next difference is the same difference, we will stop and proceed for the finding the next term, but if not the same, proceed to find the next differences. Since all the differences are equal, add all this. This is called difference table.
According to George Polya, mathematical problem solving is finding a way around a difficulty, around an obstacle, and finding a solution to a problem that is unknown. George Polya is a Hungarian mathematician and can be considered the father of problem solving in mathematics because of his many contributions in the subject. One of these is Polya's 4-step process for problem solving. It includes the understanding the problem, devise a plan, carry out the plan, and looking back.
Step 1. Understand the problem. You need to look for information given. You can ask, what is the unknown? What are the data? What are the conditions? Are the conditions sufficient to determine the unknown? Insufficient, redundant, or contradictory? You can also draw a figure, visualize the information, organize the information, and connect the information. And you could think of suitable notation for given.
Step 2. Devise a plan. We can do it by making a representation, making a calculated guess, going through the process, and revising the problem.
So this part is very important. That's why we're going to discuss the Polya strategies that we could use later in the video. Now, if we have a solid strategy or a plan for the solution, we can arrive to step 3. Carry out the plan by using our mathematical knowledge, mathematical skill, or use logical thinking. This is the solution part in the problem solving. After finding the correct solution or answer for the problem.
Step 4. Look back, check the solution, improve, and seek alternative solution if necessary.
Step number 1. Understand the problem. By looking at the problem, we can see that shape represent numbers and the first 3 equations are clues to finding the missing numbers to solve the last equation.
Step 2. Devise a plan. Whenever we see such problem, we need to translate these figures into variables. So in this case, let T be the triangle, C represent the circle, and S for the square, and X for the missing value. By writing the first equation, we will change this triangle into letter T. So we will have T plus T plus T is equal to 30. For the second equation, we will have to T plus C is equal to 18. For this third equation, we will have C minus S is equal to 2. And for the last, we will have T plus C plus S is equal. Now, by using our knowledge in algebra, we know that we can rewrite the first equation into just 3t is equal to 30. And this one can be written into 18 is equal to t plus 2c is equal to 18 because c plus c in algebra is 2c.
Step 3. So now let's carry out the plan. To solve for t in the first equation, we need to divide both sides by 3 so that t is just equal to 10 because 30 divided by 3 is now 10. If we don't have a knowledge in algebra, we can think of a number that we need to multiply to 3. For us to have 30 and that is 10, right? Since we all know that t here is 10, we can now solve for the remaining value of c. By using our knowledge again in algebra, c will be equal to 4, or just think of number that you need to multiply to 2 and adding to 10 will give us 18. That is c equals 4. Now since c here is equal to 4,
We just need to think of a number that we need to subtract from 4 for us to have an answer. So S must 2, right?
But we don't stop it there because we need to look back and check our answer. We have found out that t is equals to 10, so if this triangle is 10, adding 3 10 will give us 30. So it's correct. On the first equation, we know that we have found out that the triangle is 10 and the circle is 4. So adding 10 and 4 will give us 18. So it is also correct. On the second equation, if the circle is 4 and the square is 2, then 4 minus 2 is equals to 2. That is definitely correct. And by the confirming these three equations are correct, we can now say that this is really 10 plus 4 plus 2 is equals to 16. That is, our answer is really 16. Aside from solving a lot of problems, the best way to become skilled person solve is to learn many strategies.